Welcome back, my dear friends, my dear young friends. We have finished two chapters, complex numbers and straight lines, and we are going to the next chapter, which is sequences and series. So, are you ready for the new chapter? I always say the same thing, be relaxed, absolutely no tension because we are learning something new. Keep your mind very calm, with open mind, and definitely I will make it very simple for you to understand. Okay, you guys with me? Let's start the new chapter, sequences and series. The first thing is what exactly you mean by the word sequence. Suppose the same example that is given in your NCERT textbook. Suppose you take the number of ancestors. Suppose for 300 years back, and for every generation, say the gap is 30 years. Okay, so that means for 300 years going back, you will have 300 divided by 30, that is 10 generations before you, right? I hope you understood. I repeat once again, we are taking the number of ancestors, the numbers, okay, we have to find out that for each of the generation. And let's say each generation gap is 30 years, okay, and you have 300 years to go back. That means 300 divided by 30, you have 10 years or you have 10 generations to be counted. Okay, so you can find out the number of ancestors that you had for each generation. Now I am standing here right now in front of you. My previous generation, I would say my father, my mother, right? So you have two people right there, and each of them had their own parents, right? So my father's parents and my mother's parents, that makes it 4. Clear? And then again, each of these 4 people have their own ancestors, their parents, which again means 2 times, which will give you 8. And it goes on like this. So you have to find out the number of ancestors for the 10 generation. Okay, so in my previous first generation, I had 2. Then they had their ancestors, 4, their parents. Then they had their own parents, which is 8. And in the next step, it will again get doubled, right? It will go to 16. Correct? That will again get doubled in the next generation, 32, 64, etc. And you can find out the number of ancestors for the 10 generations. Now this forms a sequence, right? 2, 4, 8, 16, 32, 64. Understood? Now, the sequence can be either finite or infinite. If a sequence is considered just like in this problem for the 10 generations, it will end 2, 4, 8, 16, 32, 64, 128, 256, and then 512 and 1024. So it will end at 1024, right? So that is a finite sequence. It ends there. But if it doesn't end, for example, if I tell you the natural numbers, it doesn't end. 1, 2, 3, 4, 5, 6, and it goes up to infinity. Nobody can find the last number. It just goes on like that. That is an infinite sequence. Clear? And each of the members of the sequence are called the terms of the sequence. And you can count the terms. This is the first term of the sequence, the second term, the third term, fourth term, fifth term, sixth term, etc. Okay? Now we usually represent the nth term or the general term of a sequence as an. So if I write an, then that means this is the nth term of the sequence or the general term of the sequence. So what is the first term? If I put n equal to 1, I get a1. What is the second term? I get a2. Third term is a3, etc. And the nth term is an, which is the general term. Okay, so that's about sequence. You can also write the sequence of the integers, right? So you have the negative numbers and also the positive numbers. But we are interested in sequences which have a general pattern, which always have a rule where we can find out the next term from the previous term. So sequences which follow a particular pattern, we are interested in that kind of sequences. Okay, now what exactly is a series? Coming to the series, it's very simple. If you have a sequence, then how it forms a series? Just put the plus sign between these terms and that becomes a series. So once you add all the terms in a sequence, that forms a series. So that's about sequence and series, the basic understanding of that. Now, having understood what is a sequence and what is a series, let's see how to find out the different terms of a given sequence. Okay, so we have two questions here. The first question is, the nth term is given as an is equal to 3n plus 4. Okay, so we are asked to find out the first three terms of this sequence. It's very simple. Just substitute the value of n, 1, 2 and 3. When you put n equal to 1, you get the first term. When you get n equal to 2, you get the second term. N equal to 3, you get the third term. Okay, so let's solve the first problem. So I want to get the first term of this sequence, that means a1. So I put n equal to 1. So 3 into 1 is 3, 3 plus 4 is 7. So that means the first term of this sequence is 7. Okay, how do I find the second term? Just substitute n is equal to 2. So 3 into 2 is 6 plus 4, I get 10, which is the second term of the sequence. And to get the third term of the sequence, I just have to put n is equal to 3. So 3 into 3 is 9 plus 4, 13. So this shows the first three terms of this given sequence. An is equal to 3n plus 4. Clear? Any doubts? It's very simple. I don't think you will have any doubt on this. It is such a simple problem. Okay. Now let's go to the second one. You have a bit of division there, so there might some decimals coming in or some fractions coming in. Doesn't matter. Same application there also. You are asked to find out the first three terms of this sequence. I'm going to find out the first term. So what I am supposed to do? Just substitute n is equal to 1. So 2 into 1 is 2. 2 minus 3 is minus 1. So I get minus 1 divided by 4, which is the first term of this sequence. Now the second term is, again I substitute n is equal to 2. So 2 into 2 is 4. 4 minus 3 is 1. So 1 divided by 4 is 1 by 4. And I need the third term. Again I substitute n is equal to 3. So 2 into 3 is 6, 6 minus 3 is 3, so I get the answer as 3 by 4. So these are the first three terms of this given sequence. An is equal to 2n minus 3 divided by 4. I hope that is clear for you. That was a very simple problem for you. Right, so before going to the next problem, let me tell you, when I was in my plus 2, well, that was pre-degree, that was around 30 years back. And that time we don't have the plus 2, we had the pre-degree. Okay, so my favorite chapter in maths used to be sequences and series. So any problem, any difficult problem you give me in sequences series, I always love to solve it. Okay, so just tell you, in case if you have any separate or particular passion for sequence series, I'm also with you. Okay, and if you find anything difficult in this chapter, as I always tell you, please do WhatsApp in the given number. I'm always there to help you. Okay, just message me, don't call me, just message me. I'll always try to reply to you. Okay, so here we have two problems, and again we are asked to find out the nth term. Okay, this is something different. One we have the power, the other one we have some minus terms, their powers also. Don't get confused when you see all these things. It's very simple. It's all about the fear in your mind that makes the problems difficult for you. Just get rid of the problems, I mean the fear in your mind, and all the problems will be easy for you. Just trust me, believe me, because it's, from my experience I'm telling you, it's the initial fear that is definitely holding you back from solving the problems. Otherwise, it's easy for you. Okay, so let's solve it. The first problem is an is equal to 3 raised to n, it's the power of 3. So the first term you get a1 is equal to, what is it? Put n equal to 1, right? So 3 raised to 1 is 3. And a2 is, put n equal to 2, you get 3 square, which is 9. And the third term of the sequence is put n equal to 3, you get 3 raised to 3, which is 27. And I tell you, always try to by heart these numbers like 2 square, 2 cube. 2 square is 4, 2 cube is 8, 2 raised to 4 is 16, 2 raised to 5 is 32, 2 raised to 6 is 64, etc., etc. At least up to 2 raised to 10, please try to by heart that. Okay? And coming to the next problem, you have an is equal to minus 1 raised to n plus 1 into 4 raised to n minus 1. Simple it is, you will understand that once we solve it. Okay? Just put the value of n equal to 1 to get the first term. When I put n equal to 1, what do I get? Minus 1 raised to 1 plus 2. 1 plus 1. So 1 plus 1 is 2. So that becomes minus 1 raised to 2, which means minus 1 the whole square. And you know that minus 1 the whole square is plus 1. You square anything, it becomes plus. If you square a negative number, that becomes positive. So minus 1 the whole square is plus 1. So it is 1 into 4 raised to 1 minus 1. Now what is 1 minus 1? 1 minus 1 is 0. Now, many students, I don't know why they don't understand that, because all these things you learn much early in your earlier classes, in your lower classes. But many students, even when they come to plus 1, they don't know what is a number raised to 0. My dear friends, any number raised to 0 is 1. Please do understand that any number raised to the power 0 is 1. So 4 raised to 0 or 10 raised to 0 or 20 raised to 0, whatever number raised to 0 is always 1. So this is 1 into 1, which is 1. Okay, you got the first term as 1. Now to find the second term, put n equal to 2 here. So again you get minus 1 raised to 2 plus 1. 2 plus 1 is 3, which is an odd number. So minus 1 raised to 3 means it is minus 1. Minus 1 raised to an odd number is minus 1. If it is even number, it is plus 1. Okay? So minus 1 raised to 3 is minus 1 itself. Let's write minus 1 into 4 raised to 2 minus 1. What is 2 minus 1? It is 1. So 4 raised to 1 is 4 itself. And minus 1 into 4 is minus 4. You got the second term, right? Now let's find out the third term. Let's put n equal to 3. So 3 plus 1 is 4, which is even, and I told you minus 1 raised to an even term is always positive. It is plus 1. So this becomes plus 1, and this is 4 raised to 3 minus 1, which is 2. What is 4 square? It is 16. So it is basically 1 into 16, that is 16. So you get the first 3 terms as 1, minus 4 and 16. Now tell me, was that difficult or was that easy? It was easy for you, right? Right. So solving problems makes things more interesting, because life is full of problems and you are supposed to find the solutions to your problems, right? So don't get worried when you see problems on the question paper. You are supposed to solve it, and that's how you excel in your studies. Okay, so let's solve these two problems. Again, we are asked to find out the nth term. Not the nth term, the nth term is given, and in the first question you are asked to find out the 21st term. In the second question you are asked to find out the 13th and the 24th term. So let's go to the first problem, let's finish it off. Okay, so this is the nth term and you have to find out the 21st term. The only thing you have to do is just replace n by 21. Okay, so this becomes 21 into 21 minus 2 divided by 21 plus 3, which is, what is 21 minus 2? It is 19. So 21 into 19 divided by, what is 21 plus 3? It is 24, right? So you can divide these two numbers because both are multiples of 3. 21 divided by 3, I get 7. 24 divided by 3, I get 8. Now you can multiply these two and you can find out the answer. What is 19 into 7? Well, 20 into 7 is 140. So this has to be how much? You subtract 7 from 140, it will be 133, I believe. So divided by 8. So this is the 21st term of the given sequence. Okay, just check if this is right or not. I just calculated in my mind. Okay, now what is the solution for the next problem? You are asked to find out the 13th and the 24th numbers terms in this particular sequence. So let's find out the 13th term first. How do you find that? Just replace n by 13. So this is 2 into 13 minus 1. which is 26 minus 1, that is 25, right? And coming to the second part, the 24th term, again just replace n by 24, so we get something like this. 2 into 24 is 48 minus 1, which is 47. So this is how you find out the terms that are given in a particular sequence. So if you have any doubts, please do WhatsApp me, definitely I can help you. But I think this is really simple. I don't think anyone will have any doubts in this, okay? Clear? Okay, so I told you what a sequence is, what a series is, how do you find the nth term of a particular sequence, okay? Now let's go to a topic which is really important, arithmetic progression or arithmetic sequence. I told you that we are very much interested in sequences which follow a particular rule or a particular pattern, right? Because those particular sequences are of practical applications. Okay, so let's see what an arithmetic progression is. We write it as AP, okay? Arithmetic progression, I write the short form as AP. What are the main characteristic features of an arithmetic progression? Okay, I will write an example on the board and then I will explain what is an AP. Okay, suppose you write these terms 2, 4, 6, 8, 10, 12, etc. Now look at these numbers and just think what is the connection between each of the numbers. The first term of this sequence is 2, then the second term is 4, 6, 8, 10, 12, etc. How are these numbers related? Or what is the general formula for the nth term? Definitely this sequence follows a particular pattern, as it is very clearly seen from what is written here. When you add 2 to the first term, you get the second term. When you add 2 again to the second term, you get the third term. When you add 2 again to the third term, you get the fourth term, and every term you get by adding 2 to the previous term, right? Such a sequence is called an arithmetic progression because you're adding a constant number to the previous number to get the next number. Clear? That is an arithmetic progression. So there is a common difference. 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6, 10 minus 8, 12 minus 10, all will give you the same constant term 2, and that difference is called the common difference because it is common for each of the consecutive terms. Clear? And that is why it is called arithmetic progression. It is progressing. But it is not necessary that the common difference has to be positive. It can be negative also. So, suppose I write this in the reverse order. 12, 10, 8, 6, 4, 2. Then what is being added to these numbers? You are adding minus 2 to 12 to get 10. You are adding minus 2 to get 8 from 10. You are adding minus 2 to 8 to get 6, right? So here the common difference will be minus 2. So not necessary that the common difference that is being added has to be positive. It can be negative also, but still we call it an arithmetic progression, okay? Because we are adding a particular constant term to the previous term to get the new term, right? So in general, what you have to understand is that the nth term of an arithmetic progression or an arithmetic sequence will be equal to a plus n minus 1 into d. This is the basic formula or the basic equation that you need to keep in mind when it comes to solving problems in arithmetic progression. Okay, so the nth term of an AP is given by a plus n minus 1 into d. Now what is a? A is the first term. So in this example, a is 2. It is the first term. And what is d? D is the common difference. Again, in this example, the common difference is 2. It is 12 minus 10 or 10 minus 8 or 8 minus 6 or 4 minus 6 or 4 minus 2. All these yield the same value 2. So 2 is the common difference in this example. Okay, and n is the number of terms. So if you want to find out the 10th term, it will be basically a plus 10 minus 1, which is 9d. So If you want to find out any term, just subtract 1 from that term and you will get a plus that subtracted number into d as the answer. If you want to find out the 25th term of any AP, it will be a plus 24d. If you want to find out the 100th term, it will be a plus 99d. And if you want to find out the 1000th term, it will be a plus 999d. Clear? It's that simple. Once you understand this equation, you can find any term of the AP. Right? Now, if you want to find the sum of all these terms, if you want to find the sum of all these terms of an AP, for example, a finite AP, okay, suppose you have n number of terms and you want to find out the sum of these n terms of an AP, then you have the formula n by 2 into 2a plus n minus 1 into d. Or you can use the formula, this is equal to n by 2 into the first term plus the last term. And the last term is nothing but a plus n minus 1 into d. Right? If you can split this 2a as a plus a, then that a plus n minus 1 into d is nothing but an. Right? So this becomes a plus an. An is nothing but the last term, the nth term. Okay, so to find out the sum of n terms of an AP, you can use both these equations, n by 2 into 2a plus n minus 1 into d, or it is n by 2 into a plus the last term, provided you know the last term or you can find out the last term. And also you need to know the first term also. Okay, so these are the basic concepts of AP which you need to understand. What is A? It is the first term, D is the common difference, n is the number of terms, an is the nth term or maybe the last term, and Sn, the sum of n terms of the AP, is given by this equation. So please do understand these basic concepts and it will be easy for you to solve the problems in arithmetic progression. Arithmetic progression or arithmetic sequence, we have learned the basic concepts of that. Now let's solve some problems, simple problems. Let's start with, and here is the first question. It is asked to find out the sum of all the integers from 1 to 2001. It's a problem in your NCERT textbook. Sum of all integers from 1 to 2001. So clearly it is said in the question that the first term is 1 and the last term is 2001. Okay, but it is asked that you have to find out the sum of the odd integers from 1 to 2001. Not every integer, there might be even integers as well, but you are asked to find out the sum of only odd integers from 1 to 2001. Okay. So the first number is 1. Okay. But if it is asked to find out the sum of odd integers between 1 and 2001, that's a different question, because we don't take 1 and 2001 into consideration. But here, my question is, what is the sum of all the odd integers from 1 to 2001? So 1 and 2001 are also included. Okay. So the first term is 1 and my last term, I would say an, okay, is 2001. How do I find the sum? I know that the equation for the sum of n terms is n by 2 into a plus last term. Correct? Now, I need to find out the number of terms. I don't know the number of terms, right? How do I find out the number of terms? Okay. So I know that the last term is 2001, an, okay, and I also know that an is nothing but a plus n minus 1 into d. So that is equal to 2001. I know a because a is 1. So 1 plus n minus 1 into. Now tell me what is d, the common difference in this problem. The question is odd integers, right? So if 1 is the first term, what is the second term? It is 3, then comes 5, then 7, 9. So what is the difference between those odd integers? 1, 3, 5, 7, 9. It's clearly 2, right? 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. So the common difference is 2. So I put d is equal to 2. So when you ask the question, write down all these data there. A is equal to 1. AN is equal to 2001, D is equal to 2. These are the first things that you need to write on your paper. Okay, so this is equal to 2001. Now, I'm expanding this, multiplying this, so I get 1 plus n into 2 is 2n, minus 1 to 2 is 2, equal to 2001. Now let's see whether we get a whole value for n. So 2n, 1 minus 2 is minus 1, right? I take that minus 1 to the right side, so that becomes plus 1. So 2001 plus 1 is 2002. Now what is n? It is 2002 divided by 2, which is 1001. So I got the value of n as 1001, correct? Now let's substitute the value of n here. So this is equal to 1001 by 2 into first term plus last term. I know the first term is 1 and the last term is 2001. Correct? So this becomes 1001 into, now what is 1001 plus 1? Sorry, 2001 plus 1, that is 2002. Divided by 2 is again 1001. So 1001 into 1001 is 1001 the whole square. And now it's up to you to find out what is the value of this. But this is how you solve it. Okay, so I repeat, whenever you get a question like this, always write down the data first on your answer paper. A is 1, AN is 2001, D is 2. How D is 2? Because it is odd integers. So the difference between all the odd integers is 2, and then you use the formula AN is A plus n minus 1 into D. You find out the value of n, and once you get the value of n, substitute that value of n in the sum of the terms equation, and that's how you solve for the sum of the terms. You find out the answer yourself. Okay, I hope it is clear for you. Yeah. Welcome back, my dear friends, my dear young friends. We have finished 2 chapters, complex numbers and straight lines, and we are going to the next chapter, which is sequences and series. So are you ready for the new chapter? I always say the same thing: be relaxed, absolutely no tension, because we are learning something new. Keep your mind very calm, with open mind, and definitely I will make it very simple for you to understand. Okay, you guys with me? Let's start the new chapter, sequences and series. The first thing is, what exactly you mean by the word sequence? Suppose the same example that is given in your NCERT textbook. Suppose you take the number of ancestors. I mean, suppose for 300 years back, and for every generation, say the gap is 30 years. Okay, so that means for 300 years going back, you will have 300 divided by 30, that is 10 generations before you, right? I hope you understood. I repeat once again, we are taking the number of ancestors, the numbers. Okay, you have to find out that for each of the generation, and let's say each generation gap is 30 years. Okay, and you have 300 years to go back. That means 300 divided by 30, you have 10 years, or you have 10 generations to be counted. Okay, so you can find out the number of ancestors that you had for each generation. Now I am standing here right now in front of you. My previous generation, I would say my father, my mother, right? So you have 2 people right there, and each of them had their own parents, right? So my father's parents and my mother's parents, that makes it 4. Clear? And then again, each of these 4 people have their own ancestors, their parents, which again means 2 times, which will give you 8. And it goes on like this. So you have to find out the number of ancestors for the 10th generation. Okay, so in my previous first generation, I had 2. Then they had their ancestors, 4, their parents. Then they had their own parents, which is 8. And in the next step, it will again get doubled, right? It will go to 16. Correct? That will again get doubled in the next generation, 32, 64, etc. And you can find out the number of ancestors for the 10 generations. Now this forms a sequence, right? 2, 4, 8, 16, 32, 64. Understood? Now, the sequence can be either finite or infinite. If a sequence is considered just like in this problem for the 10 generations, it will end 2, 4, 8, 16, 32, 64, 128, 256, and then 512 and 1024. So it will end at 1024, right? So that is a finite sequence. It ends there. But if it doesn't end, for example, if I tell you the natural numbers, it doesn't end. 1, 2, 3, 4, 5, 6, and it goes up to infinity. Nobody can find the last number. It just goes on like that. That is an infinite sequence. Clear? And each of the members of the sequence are called the terms of the sequence. And you can count the terms. This is the first term of the sequence, the second term, the third term, fourth term, fifth term, sixth term, etc. Okay. Now we usually represent the nth term or the general term of a sequence as an. So if I write an, then that means this is the nth term of the sequence or the general term of the sequence. So what is the first term? If I put n equal to 1, I get a1. What is the second term? I get a2. Third term is a3, etc. And the nth term is an, which is the general term. Okay, so that's about sequence. You can also write the sequence of the integers, right? So you have the negative numbers and also the positive numbers. But we are interested in sequences which have a general pattern, which always have a rule where we can find out the next term from the previous term. So sequences which follow a particular pattern, we are interested in that kind of sequences. Okay, now what exactly is a series? Coming to the series, it's very simple. If you have a sequence, then how it forms a series? Just put the plus sign between these terms and that becomes a series. So once you add all the terms in a sequence, that forms a series. So that's about sequence and series, the basic understanding of that. Alright, so in the previous problem I asked you to find out the answer yourself. You might have got it as 53 plus or minus 5 divided by 8, right? Or maybe 6, yeah? So if you take plus 5, you get 58 by 8, but you don't get the answer for that. But if you get, if you take the minus value, it is 53 minus 5, which is 48 divided by whatever, it is 8 or 6. But then only you get the whole number, right? So you might get a number which is a fraction and a number which is a whole number. But always make sure that n you take is a whole number. So the answer you have to take is 53 minus 5 divided by whatever it is. I don't remember, it is 8 or 6. But you have to take 48 by that number because only that is divisible. Okay, you get a whole number. Right. Now going to the next question. So here the question goes like something. We are asked to find out the 20th term of an AP. You are asked to prove that the 20th term of an AP is minus 112 if the first term is 2 and it is given that the sum of the first 5 terms of the AP is 1/4 of the sum of the next 5 terms. Okay, so it is given that the sum of the first 5 terms is 1/4 of the sum of the next 5 terms. Okay, so it is basically S10 minus S5, correct? Because the sum of the first 5 terms is S5 and then you have the sum of the first 10 terms, which is S10. So if I subtract S10 minus S5, I obviously get the sum of the terms from 6 to 10, right? So that is the sum of the terms after the 5th term till the 10th term. Okay, so this is what is given. Now let's cross multiply this. So what I get is 4 times S5 is equal to S10 minus S5, right? Now let's bring this minus S5 to this side, so that becomes plus S5. So 5 S5 is equal to S10, or I get S10 S5 is equal to S10 by 5. Let it be this. Okay, this is the relation that I have. Let it be there. Now, I also have the information that A is equal to 2, right? Now, 5 times S5. What is S5? It is the sum of the first 5 times of the AP. So, it is nothing but 5 divided by 2 into the first term plus the last term, right? What is the first term? The first term is A and the last term is the fifth term. What is the fifth term? A plus 4D, right? Because A5 or AN is A plus N minus 1 into D. So that means A5 is A plus 4D. So the fifth term is A plus 4D, correct? Now, this is equal to S10, which is nothing but the sum of the first 10 terms. That is 10 by 2 into the first term plus the 10th term, right? Again, the first term is A, and what is the 10th term of an AP? It is A plus 9D. Okay, so A plus 9D. Now, these two gets cancelled on both sides, and I can cut this 5 and 10 also. So 5 and 10 gets cancelled. I can write 2 here, alright? So what remains is 5 times this is equal to 2 times this. Now let's add these things. So 5 into, what is A plus A? It is 2A plus 4D is equal to, we have 2 left here. Again, what is A plus A? It is 2A plus 9. Now let's open the bracket and let's add these things. Okay, so what is 5 into 2A? It is 10A plus what is 5 into 4D? It is 20D is equal to 4A plus 18D, right? Now I will take this, this A. So I will take this 4A to the left. So that becomes 10A minus 4A, which is 6A. And I will take the 20D to the right. Or let's do one thing. If I bring the 18D to the left, it becomes 2D. Yeah, it's okay. So I will do one thing. I will take the 20D to the right side. So that becomes 18D minus 20D. That is minus 2D, right? But we know the value of A, right? A is given as 2. So let's substitute the value of A and you get the value of D. So 6 into 2 is 12. So 12 is equal to minus 2D. So D is equal to 12 divided by minus 2, which is nothing but minus 6. Right? So we got the value of D as minus 6. Now what is the 20th term? That is the question. So the 20th term is nothing but A plus 19D, right? Now what is A plus 19D? It is 2 plus 19 into minus 6. Which is 2 minus 114, which is minus 112. So that is how we solve this problem. I repeat, maybe some students may not be able to understand the concept initially. The question is given as the sum of the first 5 terms is 1/4 of the sum of the next 5 terms. Now what is the sum of the next 5 terms? It's basically the difference between S10 and S5, because S10 is the sum of the first 10 terms. Right? So if you subtract S10 and S5, what you get is the sum of the terms from the 6th term to the 10th term. Clear? That is what you have to understand. So S10 minus S5 is nothing but the sum of the next 5 terms after the 5th term. Is that clear? Then you have understood the problem. So after solving these problems, we get this equation and we substitute the values. We use the equation for S5 and S10, and then you solve for A and D. We already know the value of A, so we get the value of D, and once you get the value of D, then the 20th term is A plus 19D, and you get the answer as minus 112. So we have proved the value of the 20th term as minus 112. Well, if that problem was a little bit hard for your brains, just take a break, relax, and come back again. We will have the next problem after that. Okay, and the next problem goes something like this. We are given that the sum of the first P terms of an AP is equal to the sum of the first Q terms of the AP. and we are asked to find out the sum of the P plus Q terms of the AP. I repeat, it is given that the sum of the first P terms, what is the sum of the first P terms? It is nothing but P by 2 into 2A plus P minus 1 into D. Is that clear to you? The sum of the first P terms, okay? It is equal to the sum of the first Q terms. So it is Q by 2 into 2A plus Q minus 1 into D. That is clear? The sum of first P terms is equal to the sum of first Q terms. Okay. So these two 2's get cancelled and this is what we have. And we are asked to prove or asked to find out what is the sum of the first P plus Q terms. Okay. Now let's open the bracket and let's see what we get. Okay. So multiply, you get 2AP plus P into P minus 1, right? P into P minus 1 is P square. P into minus 1 is minus P. You have D outside. Now that is equal to, again, just replace P by Q. That's the only difference there. So we get 2AQ plus Q square minus Q into D, right? So this is what you have in your equation. Now, let's do one thing. Let's bring this 2AQ to this side. So we get 2AP minus 2AQ, right? Plus P square minus P. We have D common in these two terms, right? So let this term be here itself. I am bringing this term to the left, so that becomes negative. So this becomes minus of Q square minus Q, and this whole thing is multiplied by D. Why? Because D is common in these two terms. So I have taken D outside, okay? And similarly, I can take 2A common outside in this term also. So this becomes 2A into P minus Q plus, now if I open the bracket and add or subtract these things, what do I get? P square minus Q square, right? So this becomes P square minus Q square, and then minus of minus Q is plus Q, right? So this becomes plus Q minus P into D. Correct? Now, this is equal to 0 because I have brought all the terms to the left side, so nothing is left on the right side, it is 0. So this is equal to 0. Now tell me, what is P square minus Q square? P square minus Q square, you remember the identity A square minus B square, it is A minus P into A plus B, right? So P square minus Q square is P minus Q into P plus Q. So I can write this as 2A into P minus Q plus P minus Q into P plus Q plus Q minus P into D is equal to 0. Now if you have a close look at this equation, you see that you have a common term called P minus Q in all the terms. Here you have P minus Q, here you have P minus Q, and here you have minus of P minus Q. Q minus P is nothing but minus of P minus Q, right? So I divide the entire equation by P minus Q, and what I get is 2A into, this is divided by P minus Q, that becomes 1. So, not into, this is 1. So what I have left is 2A plus, this is gone, P minus Q is gone. So what I have is P plus Q left. This is gone, and this also is gone. So what is left here? It is minus 1 that is left here because this is minus of P minus Q. Okay, so divided by P minus Q, all the P minus Q are gone. So what I have left is 2A here plus P plus Q is left here, and here you have minus 1. Right? Now, what is the sum of P plus Q terms of an AP? It is p plus q by 2 into 2a plus p plus q minus 1 into d, and we see that 2a plus p plus q minus 1 into d is 0, which is a part of the formula of Sn or Sp plus q. So sum of p plus q terms of an AP is p plus q divided by 2 into this thing. So if this is 0, then that means the sum of p plus q terms has to be 0, right? So the answer is the sum of p plus q terms of this AP is 0. So that is the answer. Okay, my dear friends, so I repeat again, I am trying to make it as simple as possible. But if you think it is still complicated for you, just let me know, just comment in the channel. I will definitely try to make it much more simpler for you. Okay, so let's move on to the next problem. Here again we have another problem in the AP arithmetic progression. We have two numbers 8 and 26, and we are asked to insert 5 numbers between 8 and 26, but the condition is that this sequence has to be in AP. Okay, so 8 is the first term and 26 is the last term. That is clear, right? And we need to insert 5 more numbers. Okay, so let the sequence be 8. Okay, and then you have A1, A2, A3, A4, A5. So these are the 5 numbers that we need to insert between 8 and 26. Clear? And once we do that, this sequence has to be in AP or arithmetic sequence. Now let's see how many terms are there in this sequence. Just count starting from 8. 1, 2, 3, 4, 5, 6 and 7, right? So we started with 8 and we are ending with 26. So we have 7 terms in the sequence. So the 7th term is 26, right? So what is the 7th term of an AP? It is A plus 6D. What is the 10th term? It is A plus 9D. What is the 14th term? It is A plus 13D. What is the 47th term? It is A plus 46D. Just subtract one number, okay? And it is easy to find out the nth term. So A7 means it is A plus 6D. Now it is given that the last term is 26. That is the 7th term. So this is equal to 26. We also know that the first term is 8. So A is 8. So 8 plus 6D is equal to 26. I take the 8 to the right side, so I get 6D is equal to 26 minus 8, which is 18, which gives me D is equal to 3. I got A and I got D. And once I get the first term and the common difference, I can write any term in the sequence. Okay? So what is the second term? That is A1, the first number I am inserting. It is nothing but 8 plus 3, which is 11. And then to get A2, I just have to add 3 to that number 11. So that is 14. Again, I add 3, so that is 17. Add 3 again, that is 20. Add 3 again, that is 23. And add 3 again, you get 26. So the numbers 8, 11, 14, 17, 20, 23, 26 are in AP. And we have successfully inserted 5 numbers between 8 and 26 so that they are in AP. Alright, so let's go to the next problem. Not the next problem, next topic actually in sequence and series. Okay, so we just completed the basic concepts of arithmetic progression. Okay, now we will go to geometric progression. Okay, now let's see what is geometric progression, or we call simply as GP. Okay, GP, geometric progression. Now how do you represent a GP, or what exactly you mean by a geometric progression? Again, let's start with a simple example. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, etc., etc. What is the thing that you can notice in this particular sequence? You see that every number is multiplied by a constant number. 2 is multiplied by 2 to get the next term. 4 is again multiplied by the same number 2 to get 8. Again you multiply 8 by 2, you get 16. Into 2 you get 32, into 2 you get 64, into 2 you get 128. So that means a constant term is being multiplied to every term to get the next term. So such a sequence is called a geometric progression, where a constant term is multiplied to the previous term to get the next term. In arithmetic progression, if you remember, a number was added to the previous term to get the new number, but in this case you multiply a constant term, right? So we call that constant term common ratio. So in AP it was common difference, in GP it is common ratio, and we denote that by the letter R. Okay, so what is R here? In this example, R is 2. And what is the nth term of a GP? How do you find the nth term? It is A into R raised to n minus 1. This is important. Please do keep this in mind. The nth term of a geometric progression is given by A, which is the first term, here it is 2 in this example, into R raised to n minus 1. So in AP it was A plus n minus 1 into D. In GP it is A into R raised to n minus 1. Okay, so please keep this in mind. This is the basic concept of a geometric progression. Okay, you multiply a constant term to get the next term. Clear? Now that we have learned the nth term of a GP, let's see what is the sum of the n terms of a geometric progression. Okay, you remember what is the sum of n terms of a arithmetic progression? N by 2 into 2a plus n minus 1 into d, right? Now let's see what is the sum of n terms of a geometric progression. We write Sn is equal to a into r raised to n minus 1 divided by r minus 1. So r can be either greater than 1 or less than 1. It can be a fraction also. Okay. So if r is greater than 1, then definitely we can use this equation, this formula, to find out the sum of the n terms. Now what if r is less than 1? Then we can write a into 1 minus r raised to n divided by 1 minus r. Okay. Just reverse it. So this is a into 1 minus r raised to n by 1 minus r, when if r is less than 1, and this is when r is greater than 1. So this is the formula for finding the sum of n terms of a GP. A into r raised to n minus 1 by r minus 1 if r is greater than 1, and a into 1 minus r the whole raised to n, 1 minus r raised to n divided by 1 minus r if r is less than 1, if r is a fraction. Okay, so just remember this formula. It is very important in solving the problems in GP. Alright, so we have solved the problem on the sum, or in fact we have learned the sum of n terms of a GP. Okay, how to find out the sum of n terms of a GP. Now we have a problem in geometric progression where the third term of the GP, that is A3, is given as 24, and the sixth term of the GP is given as 192, and we are asked to find out the 10th term of the GP. The first thing you have to do is write it down. What is the third term of a GP? It is a into r raised to 3 minus 1, right? So it is ar square. The first term is a, the second term is a into r, the third term into ar square, the third term is a into r square, the fourth term is ar cube, the fifth term is ar raised to 4, sixth term is ar raised to 5, etc., etc. Nth term is ar raised to n minus 1. Clear? Hope the pattern is clear to you. So what is the third term? It is ar square, which is equal to 24. That is already given. Now, we don't know the value of a or r, so let this equation be there. Let that be equation 1. Okay? Now let's write a6. What is a6? It is ar raised to 5, which is 192. Clear? So that is equation 2. Now let's divide the second equation by the first equation. Okay, so this is the first equation. So let's divide these two. So AR square by AR raised to 5 by AR square, that is equal to 192 divided by 24, right? And we see that A gets cancelled. Now what is R raised to 5 divided by R square? How do you find this? Both have the same base R. Here the power is 5, here the power is 2. So once you divide two terms with the same base and different powers, write the base first, subtract the two powers. So this is basically 5 minus 2, that is R cube. So R raised to 5 by R square is nothing but R cube. Okay? That is equal to 192 by 24. You divide this, how much you get? 192 by 24 is, I think, 24 into 10 is 240. So 24 into, let's try to divide this. So 192 divided by 2 is, it is, how much is that? It is 96. And 24 divided by 12 is 2 is 12. So 96 divided by 12 is 8. So 192 divided by 24 is 8. So R cube is 8 and R is equal to 2, right? Plus 2. So you got the value of R as 2, and now you can substitute that value here and you can find out the value of A. Okay, so substituting this value of R in the first equation, you get A into 2 square, that is 4, is equal to 24, which means A is equal to 24 divided by 4, which is 6. Now we got both the values of A and R, and you have to find out the 10th term. What is the 10th term? It is A into R raised to 9, right? So A is 6 and R is 2. So 6 into 2 raised to 9. And what is 2 raised to 9? 2 raised to 1 is 2. 2 raised to 5 is 32, I know that. So 2 raised to 6 is 64. 2 raised to 7 is 128. 2 raised to 8 is 256. And 2 raised to 9 is 516. So this is 6 into 516, and you find out the answer. That is how you find out the 10th term of this sequence, of this geometric progression. So this is the method. Write it down, divide the two terms, you find out R, then you substitute that value of R in any one of the equation, you find out the value of A, and once you get A and R, then you can find the 10th term as A into R raised to 9, right? So we continue with geometric progression and we move on to the next question. I hope it is going really well for you. If you have any doubts, once again I tell you, please do WhatsApp me in the given number. I'm always there to serve you. Okay. So this is the question. We have a geometric progression whose first three terms are given by 3, 3 by 2, 3 by 4. Okay. And it is given that the sum of n terms of this geometric progression is 3069 divided by 512, and we are asked to find out the number of terms. Okay, so write down each and every piece of information that you have in the question. It is given that the first term is 3. What is the common ratio? Common ratio you get by dividing the second term by the first term. That is 3 by 2 divided by 3, which is nothing but 1 by 2. Because you clearly see that when you multiply 3 by 1 by 2, you get 3 by 2. Again you multiply this term by 1 by 2, you get 3 by 4. Right? So the common ratio is 1 by 2. Either you divide the second term by the first term or the third term by the second term. Both will give you R equal to 1 by 2. Okay, so you got A and R. The sum of n terms is given. So let's write the formula for the sum of n terms. It is, please watch out, R here is 1 by 2, which is less than 1. So use the formula for R, which is less than 1. So we write A into 1 minus R raised to n divided by 1 minus R. So this is given as 3069 divided by 512, right? Now let's substitute the value of A and R. What is A here? A is 3. So 3 into 1 minus 1 by 2 raised to n divided by 1 minus 1 by 2. That is equal to 3069 divided by 512, right? Now what is 1 minus 1 by 2? It is 1 by 2, okay? So this becomes 3 divided by 1 by 2, and we can write it as 3 into 1 minus 1 by 2 raised to n equal to 3069 divided by 512 into, this is 1 by 2, so it gets cross multiplied, so the 1 by 2 comes here, okay? So we get this as 3069 divided by 1024, right? Now what is 1 minus 1 by 2? The whole raised to n. This part. This 3 will come down. So this becomes 3069 divided by 1024. Right? Now what is 1 by 2 the whole raised to n? This minus 1 by 2 the whole raised to n, that goes to the right, so that becomes positive, and this term comes to the left, that becomes negative. So I can write 1 minus 3069 by 1024. Hey, wait a minute, where has the 3 gone? There was a 3 here, right? So that 3 will come down. I forgot to write the 3 here, sorry for that. So this 3 will come down once you cross multiply. So 1 minus 1 by 2 the whole raised to n, this divided by 3. So you can cancel this. 3039 divided by 3 is how much? It will be 1023, right? So this will be 1023, correct? So this will be 1023, that is equal to I've taken this this side, so this will be equal to 1 by 2 raised to n. Okay, so this minus 1 by 2 raised to n went to the right side, it became positive, and this 1023 by 1024, it came to the left side, that became negative. Now let's take the LCM. So this becomes 1024 minus 1023, which is 1 by 1024, that is equal to 1 by 2 raised to n. Now tell me, which power of 2 will give you 1024? Well, it is 2 raised to 10. Okay, 2 raised to 10 is 1024, so n is 10. That means you need 10 terms of this particular sequence, this particular geometric progression, to give you a sum 3069 divided by 512. Going on to the next problem in geometric progression. Here's the question. We have the sum of the first 3 terms of a geometric progression is given by 13 by 12, and that product is given as minus 1. And we have to find the first 3 terms and the common ratio. Okay. So in these types of problems where the sum of the first 3 terms is given and the product is also given, we have to keep in mind that the way we take the 3 terms, it should be like this. Let the first 3 terms be A by R, A and AR. Why did we take that like that? Any idea? Because the product is given, right? So if we take the 3 terms as A by R and A and AR, when we multiply these 3 terms, obviously the R will get cancelled and you get a cube is equal to minus 1. You will get a from that, and once you get a, you can substitute in the sum and you can find out the value of the missing term. Okay, so that's why we have taken the three terms like this. So whenever you have the product of three terms given, always take the three terms as a by r, a and ar, because clearly r is multiplied in every term to get the next term, right? So it's a GP. Now, just like I said, multiply these two terms, r gets cancelled and you get a cube, that is the product of three terms is given as minus 1, you get a is equal to minus 1. Okay, now substitute this value of a in the sum. Okay, so it is given that the sum of the three terms, which is a by r plus ar, is given as 13 divided by 12. Substituting the value of minus 1, we get a is minus 1, so minus 1 by r minus 1 minus r is equal to 13 by 12, right? So I have substituted a equal to minus 1 in the equation of the sum. I got minus 1 by r minus 1 minus r is equal to 13 by 12. Now, all the terms in the left side is negative. Let's transfer that negative to the right side. Okay, so this becomes 1 by r plus 1 plus r is equal to minus 13 by 12, right? Let's take the LCM on the left side, which is r. So each of the term gets multiplied by r here, the second term and the third term, because here the denominator is 1, here also the denominator is 1, but here the denominator is r. So the LCM is r, so both these terms multiply by r and the whole term gets divided by r. So we can write 1 plus r into r square, the whole by r is equal to minus 13 by 12, right? Now we can cross multiply and we can write this as 12 comes here and r goes here. So 12 into 1 is 12 plus 12 into r is 12r plus 12 into r square is 12r square equal to minus 13r. Now we can take this minus 13r to the left side, it becomes positive. We can write the r square term first. So this becomes 12r square. 13r plus 12r is 25r plus 12 is equal to 0. So clearly we get a quadratic equation in r. You can solve this equation by using the formula, that is r is equal to minus b, which is minus 25, plus or minus root of b square, which is 25 square, that is 625, minus 4ac, that is 4 into 12 into 12, 12 into 12 is 144. So what is 144 into 4? 4 into 4 is 16. So you get 576. Divide by 2a, a is 12 here, so 2a is 24. So this becomes minus 25 plus or minus, this difference will give you 49. Square root of 49 is 7. And you have to solve for this. So this becomes minus 25 plus 7, which is minus 18 by 24. Or you get minus 25 minus 7, which is minus 32 by 24. Now, this will give you can reduce this, divide this by say 6, so this will give you minus 3 by 4. Again we can divide this by 8, this will give you 4 by 3, so this is minus 3 by 4, or this is minus 4 by 3. So we have got the value as r is equal to minus 3 by 4 or r is equal to minus 4 by 3. Now substitute the values and you will get the terms. So a was minus 1. So a by r means minus 1 divided by minus 3 by 4. A is obviously minus 1. AR is minus 1 into minus 3 by 4. So the terms are minus and minus gets cancelled. This becomes 4 by 3. Minus 1 and 3 by 4, and similarly you can substitute the value of minus 4 by 3 and find out the sequence. So this is how we solved this problem. Okay, so still working on geometric progression, and I am ready with the next problem. Are you guys ready? Come on, let's solve it. Okay, so this is actually a very important problem, usually asked many times in your board exams. Very important one. So you have a particular method to solve this problem. Okay, so practice more on this and you will get you'll find it easy once you practice it again and again. Okay, so let's see how we can solve this. We need to find the sum of the n terms. The first term is 8, the second term is 88, 888, 8888, etc., etc. But once we see this, we see that it is not a GP, but we can definitely work on this and try to convert this to a GP. But how do we do that? Let's write this as 8 plus 88 plus 888 plus 8888 plus etc. up to n terms. Okay. Now, we can write this like this. 8 into 1 plus 11 plus 111 plus 1111 plus etc. up to n terms. Correct? Is that clear to you? I have taken 8 outside and I have written the inside like this. 1 plus 11 plus, because 8 into 1 is 8, 8 and 11 is 88, etc., etc. Okay, understood? Now, let's multiply and divide this by 9. Why? If I divide this by 9 and multiply by 9, what I get is 9 plus 99 plus 999 plus 9999 plus etc. again up to n terms. Okay? Why did I do this? Because in the next step I can write this as 9 is nothing but 10 minus 1. And 99 is 10 square minus 1, 100 minus 1, correct? And what is 999? It is 1000 minus 1 or 10 cube minus 1 plus etc. up to n terms. Okay? Now I can combine the first terms of each of these together, which is nothing but 8 by 9 into, I write the tens, the powers of 10 first. Okay? So 10 plus 10 square plus 10 cube plus etc. up to n terms. Correct? Then minus 1 is the second term in each of these, right? Minus 1 here, minus 1 here, minus 1 here, like that n terms. Okay, so all these minus 1s when added together for n terms we get minus n, right? So minus 1 added n times means it is minus n. So that will yield you minus n. Correct? Now, this what you find inside the bracket is definitely a GP. Correct? Because the first term is 10, then 10 square, 10 cube, etc., etc. up to n terms. So this is nothing but the sum of n terms with first term 10 and common ratio 10. Correct? So what is the answer for that? The sum of n terms is a into r raised to n minus 1 by r minus 1. Here n and r both are 10. So this is 10 into 10 raised to n minus 1 by 10 minus 1, which is 9 minus n. Right? So this is the answer to this particular problem, but you have to always keep in mind that there is a particular method, this method, to solve this problem. So practice makes perfect. Do practice this very often and you will find it really easy. Okay. Alright, so we are still going on very strongly with geometric progression. And if you see, I have written on the board two things. One is AM and it's not AM and PM, it's AM and GM. So what exactly I am trying to tell you? AM is arithmetic mean and GM is geometric mean. Okay, so we are going through the geometric progression, but let's get this two, the AM also, okay, since they are connected, they are both means, okay, the mean value, okay. So let's go to AM. What do you mean by AM? Arithmetic mean means if you have two numbers A and B, and suppose if you have a number, say A, I write capital A, okay, in between A and B, such that these three numbers form an AP, an arithmetic progression. Then we know that the common difference has to be the same, right? The difference between these two terms has to be equal to the difference between these two terms. So we can write A minus A is equal to B minus A, correct? Now, I will take this minus A to the left, that becomes plus A. So A plus A becomes 2A, and this minus A goes to the right, which becomes positive, that is A plus B. So what is capital A? It is A plus B divided by 2. This is nothing but the average, right? A plus B by 2 is nothing but the average or the mean of the two values A and B. So what is A? It is clearly the arithmetic mean of the two numbers A and B. So when you say arithmetic mean, A is nothing but A plus B by 2, right? Now what is GM? Obviously it is something related to geometric progression, okay? So we know that if A and B are in GP, or if we try to include another number, I would say capital G, which obviously is the geometric mean. We know that these three numbers are in GP, okay? So how do you find G? Just like we found out A. And if these three numbers are in geometric progression, then we know that G divided by A is equal to B divided by G, correct? Because they are in GP. So G divided by A and B divided by G has to be equal, the common ratio. Cross multiply, you get G square is equal to AB, or I can say G is equal to square root of AB. So the geometric mean between two numbers AB is nothing but square root of AB. So the arithmetic mean between A and B is A plus B by 2, and the geometric mean G is given by square root of AB. These two are very important, please keep in mind. Okay, so I am ready for the next war, ready for the next action. We have to find out numbers between 3 and 243, which when inserted form a GP. So this sequence has to form a GP by inserting certain numbers between 3 and 243. Okay, so I have to insert three numbers between 3 and 243 so that these numbers form a geometric progression. Now, let's see how do we write that. So one thing is very clear that this is a GP, right? Suppose we include three terms starting with 3, okay. So our first term is 3 and we have to include three terms between 3 and 243 so that the resulting sequence is a GP, okay. So when I add G1, G2, G3 between 3 and 243, then I see that 243 is 1, 2, 3, 4, 5, the fifth term of this GP. Is that clear to you? Yes. So what is the fifth term of a GP? It is nothing but AR raised to 4, correct? So that is 243, and I also know that A is 3. Okay, so 3 into R raised to 4 is 243, which means R raised to 4 is 243 divided by 3, which is 81, and I get which number raised to the power 4 will give you 81. Just think, it is 3 into 3, 9, into 3, 27, into 3, 81. So the fourth power of 3 is 81. That means R is 3, because 3 raised to 4 is 81, right? So I have A equal to 3 and R is equal to 3. So which are the numbers? The first number is 3, R is 3, so multiply 3, you get 9, again multiply 3, you get 27, multiply this by 3, you get 81, multiply this by 3, you get 243. So what I have done is correct, because the sequence has come out right with the first term 3 and the last term 243. So these are the three geometric means which I have inserted: 9, 27, 81, and this sequence is in a GP. One mistake which everyone does in this problem, including me, is we usually tend to forget the negative value. Okay, we saw that R raised to 4 is 81. Initially I wrote R is equal to 3, but it's not just R is equal to 3, R is plus or minus 3, because plus 3 the whole raised to 4 is 81. At the same time, minus 3 the whole raised to 4 is also 81. Okay, so when you have an even number here, always make sure that you take the plus or minus value. Okay, so already we got the sequence for R equal to 3, but we have to consider the sequence for R is equal to minus 3 as well. Okay, so if R is minus 3, then the sequence is 3, then multiply 3 by minus 3, which is minus 9. Again multiply that by minus 3, which is 27. Multiply again by minus 3, which is minus 81. Again into minus 3, you got 243. Okay, so make sure that you don't forget to take both the plus sign and the minus sign. So you have two different sequences. One is 3, 9, 27, 81, 243 for the plus value of R, but you also should write the sequence for the negative value of R. Okay, so don't forget to write both the sequence. So this is the second sequence. This also satisfies the condition that these three numbers, when inserted between 3 and 243, it results in a GP. Shall we go to the next problem? Again, continuing with GP, this is the problem that is given to us. It is given that the sum of the first two terms of the GP is minus 4, and the condition that the fifth term of the GP is 4 times the third term. Okay, so this is the data that is given to us, and we have to find out the GP. Okay, now the first term is nothing but A. Okay, so we will write the first term as A, and the second term is A into R. Okay, so the sum of first two terms is A plus AR, which is equal to minus 4, and it is given that the fifth term is AR raised to 4, right, is 4 times the third term, which is AR raised to 2. Clear? Fifth term is AR raised to 4 and third term is AR squared. We can divide A by A, it gets cancelled. R raised to 4 by R square is R square. So R square is equal to 4, which means you should take both the values of plus and minus. Okay, square root of 4 you should take plus 2 as well as minus 2. Usually we take only the plus value, we tend to forget that, but please do remember, always take the plus and the minus sign. So R is equal to plus or minus 2, so obviously you get two sequences, no problem, that is the answer. Okay, so first we get R equal to plus 2, that means if you substitute R is equal to plus 2, what do you get? A plus 2A is equal to 4, right? R is 2. So that is nothing but 3A is equal to 4, or A is equal to 4 by 3, correct? Now, if A is 4 by 3 and R is 2, what is the next term? It is 4 by 3 is the first term, and the next term is 4 by 3 into 2, which is 8 by 3, correct? And obviously the next term will be into 2, which is 16 by 3, etc. So that is one sequence, one GP. Now what if R is minus 2? If R is minus 2, then what do I get here in this equation? A minus 2a is equal to minus 4. Oh, wait a minute, I made a mistake here. This is minus 4, right? So a plus 2a is minus 4. Okay, so it is minus here. So let's put minus here. So this is minus 4 by 3, minus 8 by 3, minus 16 by 3. Okay. Now what if r is equal to minus 2? A minus 2a is equal to minus 4. Now what is a minus 2a? It is minus a. So minus a is equal to minus 4, which means a is equal to 4, right? And if I substitute the values here, what is the first term? A is 4. And what is the second term? It is AR, which is 4 into, what was R? R is minus 2, right? So it is minus 8, okay? And the next term is minus 2 into, minus 8 into minus 2, which is 16, and it goes like this. So we get two sequences, 2 GPs. This is the first one for r equal to 2, a is minus 4 by 3, and this is the second one, 4 minus 8, 16, where a is 4 and r is minus 2. Alright, so going to the last topic in sequences and series, it is a very special series. We have to find out the sum of 3 different special series, but that is really important. You have to memorize that. I will write that. Okay, so the first thing is you are asked to find out the sum of n terms of first n natural numbers. Okay, up to n terms. The first term is 1, second term is 2, 3, 4, etc. So these are nothing but the sum of the first n terms of natural numbers. Okay, just remember this, the sum of first n terms of natural numbers is n into n plus 1 by 2. Okay, you can definitely find this using the formula, the sum of n terms, which is n by 2 into first term plus last term, or n by 2 into 2a plus n minus 1 into d. Here a is 1, the first term is 1, and the common difference is 1. So applying that value of a equal to 1 and common difference d is equal to 1, in the formula sum of n terms, definitely you can arrive at this equation. But just memorize this just by heart it. The sum of n terms of first n natural numbers is n into n plus 1 by 2. Now the second series is you have to find out the sum of the squares of first n natural numbers. Again n terms, okay? Just remember this formula, the sum of n terms of first n natural numbers, squares of first n natural numbers is n into n plus 1 into 2n plus 1 divided by 6, okay? Just by heart this. And the third special series is the sum of the cubes of the first n natural numbers. So 1 cube plus 2 cube plus 3 cube plus etc. Again up to n terms. Now that is interesting because we know that the sum of n terms of first n natural numbers is n into n plus 1 by 2. If you know that, then the sum of cubes of first n natural numbers is nothing but the square of this. Okay, so this is equal to square of this, which is n square into n plus 1 the whole square divided by 4. Okay, so these are the 3 special series: the sum of first n natural numbers, sum of the squares of first n natural numbers, and the sum of cubes of first n natural numbers. So remember these 3 formulas and you will be able to solve the problems related to these. Okay.